So, you first.
No, you.
Okay.
Go ahead.
All right. So, let's sum up these puppies.
Okay, so here's the thing we've been hinting at this whole time.
The whole time.
If you have a geometric series, which by the way has this form, an infinite geometric series.
It's got to be infinite.
It converges if and only if the absolute value of r is less than 1. So
now, it could still be 0.99999.
But that's less than
it's
1.
less than 1.
And if it's negative, they're saying that's okay, as long as basically we have a fraction that is like an actual fraction. Not like 3 over 2, that's bigger than 1.
That's bigger than 1.
A fraction that's less than 1. If that's what happens, then the sum converges, and
it converges to that right there.
A over 1 minus r, and this is A1 and A1. I don't really like how the book kind of drops out the A1 thing, but it's whatever. So let's do some, right? Example 6. Determine whether the series converges. If it converges, give the sum. So one thing you're trying to look at is this even like a geometric sequence? Like, here we have something that looks exactly like this.
I mean, freaking identical.
Where r is 0.75. That
3/4 maybe, if you want to go that way.
If you wanted to, and that is less than 1, so this does converge. We can figure out where it converges by doing a, which is 3, over 1 minus r, which is 0.75.
I'm on it right now.
I think it's 12.
3 divided by 1 minus, what's 5? It's 12.
Bam.
You're so good. It's like you're getting a master's in mathematics.
Converges to 12. All right, so here, you might be like, oh, this looks a little different.
I still say we can do that one.
Because
we can
what
get
they
a
did
first term.
When you subtract 1 from this, you add 1, like they're backwards, and so that still works out.
Right.
That's still okay. And so it is negative, but that's okay. So we should have, since it doesn't tell us, that's a 1 in front, right? 1 over 1 minus a negative 4/5.
We could also find the first term, right? We could just put 0 in for n.
Oh, you could, yeah.
I mean,
and then that'd
it's
be
going to be 1.
Yeah,
so.
that's true.
Okay, so I'm on it right now. 1 divided by 1 minus negative 4/5, 5/9. But how did you get that already?
I just showed off. It's okay.
Man.
All right, so
You're brilliant.
this one, okay, looks like kind of a combination of these, but before we even worry about if the n equals 1 and the n is okay, check this out. Pi over 2 is like 1.7.
Okay, I'll just punch that one in there. Pi divided by 2.
something.
1.570796326679.
And so that is bigger than 1, so this diverges. It's not going to go towards a certain number.
Pi over 4 though would work, right?
Yeah, it would. Pi over 4 would work, and then we would have to go on with that. This one right here is not written in summation notation, which is a little annoying. But we can still find
we got
A
a first
and R,
term though.
and we can figure, because A1 is 1, and then R is, what are we multiplying by each time?
It looks like a half. Looks like a positive half even.
And so that is something that should converge, and we can just plug it in.
I like how you're thinking. So 1 divided by 1.
I bet you can do this without the calculator.
Okay, hold on.
No, do it without the calculator.
No, what are you doing?
Do it without the calculator. Come on, use your math.
3 halves.
Okay, I forgot because I thought about it. And no, it's not 3 halves.
2.
Yes, 2.
Oh, thank goodness.
Okay.
2 guesses every time.
At least.